Ladies and gentlemen, hello once again, and welcome back to the briefing room. My name is Eric Cavanaugh, and I will be your moderator for today's event, in which we're going to delve into, once again, one of these incredibly hot topics that we have here in the field of information management. We're going to be talking all about this thing called Hadoop and this concept of big data. And boy, it's just everywhere these days. So the specific title of the presentation today is In the Mix, How Native Integration Improves MapReduce and Hadoop. So let me just dive right in here. There's a slide about yours truly, and enough about me. The mission, as many of you now know, of the briefing room is really to reveal the essential characteristics of these technologies. So in order to do that, we've taken a rather different approach from every other webcast I've seen in the business. The analyst and vendor do not coordinate before the show. And the idea there is we want to expose an organic discussion between a vendor and an analyst about a particular technology, how it works, why it was designed a certain way, what it does, where it fits into a broader ecosystem. So today we're, of course, talking about this concept of big data. And you can see we have different topics every month there. Analytics is this month. Intelligence is next month. July is governance and disruptive technology. We're doing analytics again in August, and we've sold out May, June, and August, and I think we have 1 or 2 slots left in July, so hopefully we'll sell those too. So analytics, you know, we talk a lot about business intelligence in this show, and analytics gets outside of that. As you can see, there are all different kinds of analytics, and with big data, one of the problems, of course, is that it is so unwieldy. It doesn't fit neatly into the traditional relational database model. So it's a bit more difficult to work with, and that's why we've seen this just cascade of new tools and new connectors come down the pike to help people better get a handle on this stuff. So first, of course, you've got to bring it in, then you have to be able to do your analysis on it. And what is really fascinating to me is to see this nexus of open source software and closed source software. Of course, closed source is where you don't get to see the source code unless you're on the development team or have a really good relationship with the vendor. Open source is this whole movement that was founded really by Linus Torvalds, who created Linux with the help of IBM, who invested probably about $1 billion or so. And I've been told by various sources that IBM recouped that investment within something like 18 months, depending upon the estimates. And obviously, one of the main reasons why IBM did that was to fend off Microsoft, because Microsoft owned the operating system market, and so everybody had to write for Microsoft. And as many of you know, Microsoft kept coming out with new operating systems. Of course, they had a lot of trouble with Vista when it first came out. And anyway, if the foundation keeps changing, that makes life very difficult, especially for people who are not close partners. So competitors with Microsoft were having a pretty difficult time with that, hence the investment into Linux. And now every enterprise software vendor that I know of writes for Linux. So what we're seeing here in this whole space around analytics is this integration of MapReduce and Hadoop, which are, of course, open source projects. There are also a lot of other open source projects like Cassandra and MongoDB and these other database projects that are happening out there. And you see a lot of times, well, almost all the time, you'll have some kind of commercial entity that sits on top of that. With Linux, it's Red Hat, for example. There are other distributions, but there's a way that people make money, right? Open source software isn't designed just to give out free software. But obviously, people want to make money doing this kind of stuff. But nonetheless, I think it is absolutely fascinating to see all of these different enterprise software companies embracing open source. It's everywhere these days. All kinds of vendors are talking about connectors to open source, to Hadoop, and to MapReduce. So it's exciting times, folks. So here is a slide about our analyst, Robin Bloor. He's chief analyst here at the Bloor Group. He's going to be the analyst today, and we're going to talk about SAP Sybase IQ. So many of you know Sybase IQ. It's been around for a long time. It's arguably the longest standing significant columnar database in the marketplace. Of course, columnar databases are very popular these days. They're all over the place, lots of different columnar approaches. And Sybase IQ is arguably the first major one. I'm sure we could find some others if we dug deep enough. So we're going to hear from David Jonker and Courtney Claussen over there at Sybase IQ, now an SAP company. And we've talked about the integration as well. And I can tell you from my perspective, it certainly appears as though SAP is doing its best to fully integrate the Sybase stack. So that's good news for Sybase users, obviously, but it's good news across the board, I think. So with that, I'm going to push the first slide here for David and Courtney, and I'm going to hand over the keys at 5 past the hour. The floor is yours.
Excellent. Thanks, Eric, and thanks for having us. I'm really looking forward to the conversation in a few minutes. Obviously, we want to take a bit of time, tell you guys about Sybase IQ. Maybe you don't know a whole lot about it. As Eric was mentioning, we're one of the first significant column databases in the marketplace, and in fact, actually the first commercial column database that was offered in the marketplace over 15 years ago. So it has been in the market for a very long time, and in fact we actually have more customers than all the other column databases out there. And you know, that's not marketing hoo-ha. You know, we've seen what our competitors have said, how many customers they have. You know, we've got well over 2,000 customers in production with Sybase IQ, and a lot of the other columnar databases aren't quite there. Of course, a lot of people don't actually know that about Sybase IQ. I think that fault lies with me being in the product marketing organization and responsible for marketing the product. But hey, you know, the beautiful thing is that a lot of people have adopted it and had success with it. And this slide just kind of talks to that really quickly. You know, Sybase IQ at the end of the day really kind of used heavily in reporting for a long time. Often would get deployed as a data mart. Primarily to start, where they had existing databases that needed to accelerate performance in some way, shape, or form. We would go in, prove out the use of a column database well before column databases were popular, and you know, they wouldn't actually believe us that the database could actually do that. You know, they'd actually have people check and recheck the results, convinced that in fact actually the Sybase IQ database must be coming back with wrong results. You know, nothing that fast could actually give the right result. And but of course, column databases have become much more popular. So also get used heavily in terms of analytics. And so we've been used heavily in financial services. A lot of financial institutions use us to run complex models, you know, trading algorithms, that kind of stuff, figure out risk exposure, that kind of thing. If you live in the U.S., I don't. I'm in Canada, so I'm safe. But if you live in the U.S., then you know, the IRS is actually using IQ to analyze your tax return and decide how much of a criminal they think you might be and whether they should actually do an audit on you or not. So it gets used in many different places. Obviously, today we're talking about big data, and that's been a huge focus for Sybase IQ. And you know, from my perspective, big data is first and foremost, it's a huge opportunity. It's a huge opportunity to uncover insights that you didn't know before, turn that into value, and a lot of the early leaders in adopting big data are having a lot of success and in terms of delivering that. So it's an opportunity. We often talk about big data as this problem, but reality is that, you know, companies don't actually have to adopt big data. You know, maybe for certain regulatory requirements you have to adopt big data, but definitely not, you don't have to adopt big data analytics. You know, that's a choice to make because you see the opportunity. Obviously, that opportunity creates some challenges for a lot of companies, especially if you've got an infrastructure, you know, that was that's not optimized to deal with large volumes of data, deal with analytic kind of queries, that kind of stuff. And I know we've probably all heard about it, right? The volume side of the house, the variety side of the house, velocity, so on and so forth. And you know, those are definitely problems, right? And if you don't have the right infrastructure to handle that, you're going to run into challenges or limitations. You know, there's a kind of glass ceiling in terms of how far you can go. But two other areas that at Sybase we often talk about, or with Sybase IQ, we talk about skills. Skills is actually a big issue, especially when you start talking about a lot of the open source technologies. Hadoop has a lot of potential power in it, and for certain use cases from our perspective, and we're going to talk about that today. But one of the big challenges with Hadoop is the skill set that's required, and so often people don't have that. And so how do you overcome some of that and leverage that, or move past that, if you like, in order to leverage some of these open source technologies in your environment? Also, a big issue is from skills perspective is how do you integrate this with your existing skills or your existing environment? You know, companies have spent literally billions and billions and billions of dollars installing their data warehouses, installing their transactional databases, building all that infrastructure. And sometimes, you know, the vision, there's some very strong visions out there about how Hadoop will get used for everything, right? It's the data warehouse of the future. You know, but that kind of forgets the fact that companies have invested so much in a set of skills, a set of technologies that you know, do very well, that meet a need, and otherwise companies wouldn't have invested in that. And then the cost side of the house too. You know, especially if you've got outdated infrastructure, you know, it can be very expensive to manage a lot of data and analyze it. And so how do you handle that? How do you find cheaper ways to acquire the data, analyze it, and turn it into value? So with Sybase IQ 15, we're going to talk. I know we're going to go into 15.4 and the Hadoop stuff, and Courtney Claussen is going to dig into that, share a lot of her technical expertise with you guys. But just kind of give a bit of background on Sybase IQ. So we had the version 15 platform has come out over essentially the last 3 years. And we've actually had 5 different releases around it as part of the 15 platform. And the 15 platform, you know, back in when we started planning it, so that would have been like 2007, 2008 timeframe, there was a recognition that the market was going to change, and how do we create a new platform to address that? And so when you take a look at everything that we've done in the 15 family, it's been all around how do you grow to deal with all of these issues? How do you deal with more larger volumes of data, deal with data coming in and analyzing it at a much faster pace, deal with a variety of data, right, different data types, all that kind of stuff. And so we've re-architected our entire platform to deal with this. To handle this. And in fact, actually, if we take a look at the architecture, back in the day, if you took a look at Sybase IQ 15 years ago, right, obviously 15 years ago was the first columnar database. It was version 1, that kind of thing. You know, it was pretty limited in terms of what it's done, and obviously we've grown the product significantly over the years. But even, you know, say, you know, 5 or 6 years ago was primarily, you know, a single server database. Yeah, we had customers that would deploy more than one server, you know, connecting to a central database. But that's primarily what it was. And as part of the 15 re-architecture, we reinvented it as a grid of databases. It uses a shared everything architecture as opposed to a shared nothing architecture. That's fundamentally different than most of the other column database vendors in the marketplace. We actually believe that it's a much more scalable architecture, shared everything versus shared nothing. We won't go into it right now, but if you got questions about it, go for it. You know, ask, and we can have that conversation later. But we actually believe that it's fundamentally more scalable and much more flexible. And you can create multiple communities on this grid of servers that can have dedicated resources to do whatever it is they want to do. They can run those complex queries. They can do basic reporting. You know, you can deploy into production environments, whatever it is. So that's fundamental at the database level. And then we've added these application services in the 15 family. We've recognized that more and more when you're starting to deal with big data analytics, it's not just about the database, but it's about all of the services that you can put around that. So some of those services are just basic APIs, right, like Java and SQL and C++, ways to access the information. But we've also built a lot of capabilities into it as well. So for example, we've added the ability to add lots of analytic libraries and algorithms and run them directly inside the database. And I'm sure a lot of you have heard about this concept, but basically the idea is that when you start to deal with big data, you can't really take the data out of the database, ship it to the tool, and then run your queries there. right? If you're a data scientist or an analyst today, you know what a problem that is. So you're dealing with sampling of the data. Sometimes sampling makes sense, right? And sampling does make sense in many cases, depending on the kind of algorithm that you're running. But to deal with massive amounts of data that you want to analyze, you might end up sampling down far more than you really want to. But so the idea of in-database analytics is to say, hey, take the algorithms, rather than taking the data to the algorithms, take the algorithms to the data. So put the algorithms in the database and run them there. And so with Sybase IQ, we've built that in. We've also built in some APIs, so you can actually add your own custom algorithms into the database. And it's these APIs, in fact, actually that we use to implement our own MapReduce API, an algorithm on top of that. And Courtney will talk about that a little bit. It's also how we integrate third-party libraries like Predictive Markup Model Language with Zementis. Fuzzy Logics has a number of DBlytic libraries. They've got hundreds of algorithms, advanced data mining and statistical algorithms that we can run in database as well. And that's all provided at the application services layer. It's at the application services layer too in our new architecture that we integrate with environments like Hadoop or other unstructured data sources, and have ways to move the data in, move the data out, query across it, so on and so forth. And then the last element to our new platform is actually around the ecosystem. And obviously the list here has a lot of Sybase or SAP products that are part of the ecosystem. But we've been very aggressive about going after and growing the number of ISVs, right? So I already mentioned Zementis. I've mentioned Fuzzy Logics, companies like KXEN, for example. So you can create your predictive models, run them in IQ, and deliver results in that way. And we've got lots of customers that are doing that kind of thing. So that's kind of the high level of the platform. And within this framework, within this architecture, we've added the ability to run MapReduce, and you can run it. We have our own native MapReduce APIs. So you don't actually have to use Hadoop if you don't want to. You can actually store the data in IQ, and you can do that. And you can run the MapReduce algorithm in a massively parallel way across the whole grid, and Courtney will talk about that. But we can also integrate with Hadoop, like I mentioned. And so why don't we actually switch it over, and why don't I give it over to Courtney so that she can actually go into detail into how we do our MapReduce and how we integrate with Hadoop.
Thank you very much, David. My name is Courtney Claussen. I'm a product manager for Sybase IQ, and I'll be digging into some of the technical details. Go to the next slide. David Jonker talked about in-database analytics and interaction with other environments such as Hadoop, and we achieve this through an extensibility framework. This allows partners and users to write custom functions and invoke them from SQL. These functions adhere to a published API, and they're loaded as dynamically linked libraries that execute in the same process space as the database server. So you eliminate the overhead of moving data into a separate environment for advanced analysis. The processing is moved close to the data, not the other way around. Along with performance benefits, this allows analytical code to be shared by all users who have access rights to the database. This way the analytical models stay current. And with Sybase IQ's superior ad hoc query capabilities, this gives the user the flexibility to run different kinds of queries on the fly. Sybase IQ, as David mentioned, has been aggressive in our partnerships with companies that build specialized software and solutions, and we have worked with them to integrate their solutions or software with Sybase IQ and to run them within the database. This slide shows a huge list of functions that we have incorporated into Sybase IQ through our relationship with a company called Fuzzy Logics. This is a company composed of really smart mathematicians who have built a tremendous library of mathematical and statistical functions. We are in a close partnership with them, And we have certified their libraries. And you have now at your disposal from SQL queries all these incredibly advanced, deep algorithms to make use of in your analytics. This extensibility framework has several different APIs associated with it. They're pretty simple, easy to understand. We have various models of functions. We have scalar to scalar, and you would use these kind of functions any place in a SQL select statement where you could use something that an operator that operated on a single value, such as a sine or a cosine or a string function. We have scalar set to scalar functions, so any place you can operate on a set of data, such as max or min or count. That's where you would use one of these. And then they're advanced. They become more advanced in terms of some of their complexity, is the ability to take bulk data in and bulk data out. And the kind of epitome of all of this, this advanced bulk in and bulk output type API, can be used to do MapReduce-like processing right within the database, which is very similar to what you do in a Hadoop environment. The functions I just showed you, the APIs I just showed you, are available in C++, and these operate within the same process space as the database engine. So they're in the same memory space, the same process space. They run very, very fast. However, we've also recognized that for security reasons, safety reasons, so you're worried about changing any kind of data in the memory space, we have also created Java APIs, and these run in a Java virtual machine, still close to the data, but in their own process space, and they still run very fast, but they are a little bit safer if you're writing your own functions and they haven't had full certification from Sybase. We have had a partner called Zementis who used these Java functions to build a very interesting piece of software. It's a PMML plugin, where they convert PMML or a predictive model into Java code, and then they link that Java code into Sybase IQ through this Java UDF, and it executes within Sybase IQ for running predictive analytics right within the database. Now let's move on to our integration with Hadoop. Our integration with Hadoop builds on this extensibility framework that we used for in-database analytics, predictive analytics, and integration with partner libraries. We use the same extensibility framework for integrating with Hadoop. And we have, recognizing that individuals have different kind of needs and may want to integrate in different kind of ways, we have introduced 4 different integration methods with Hadoop. Our first integration method is something we call client-side federation. And this is accomplished through an association with the Quest company, who builds the very popular Toad data management tool. And we've worked with them to create a client-side federation capability by which you can join data from Sybase IQ and join data from Hadoop and present it at the client application level. And for each one of these 4 methods that I'm going to be talking about, we have some suggested use cases where you might use this particular integration method. The client-side federation method is most pertinent when you have already aggregated results in Hadoop and already aggregated results in Sybase IQ, and you're not bringing a lot of data back to the client. An example might be in telecommunications, aggregated customer loyalty data in Hadoop, in your Sybase IQ database, and aggregated network utilization data in Hadoop, and combining those for analysis on customer loyalty. Our second method of integration is ETL. we have worked with Cloudera, a commercial provider of Hadoop distributions, who has built the Scoop ETL tool, which lets you move data between Hadoop and relational databases. And they now support Scoop doing ETL from Hadoop into IQ for deeper analysis. This is the case where you actually might want to bring that data into IQ and leave it there and use it for different purposes over time. It's not really that transient. You can make use of it inside the database for different purposes. And one example might be an e-commerce application where you're analyzing clickstream data from web logs, you're storing them into IQ, and then doing various analysis against your transactional sales data that's sitting in Sybase IQ. Then we have data and query federation. It's the final two methods of integration. Data federation lets you federate data that's sitting in the Hadoop file system. It's the results of a MapReduce job. And you can federate it, meaning that when you can select it like you would data from a database table. And in a select statement, you bring in the Hadoop data. It looks like a table, and you can join it with IQ data. In this case, where data is, you really don't want to bring all this data into IQ. You're not going to be using it for multiple purposes, or for some reason you don't really need to have it inside the database at all. It's perfectly fine sitting in Hadoop and being represented as a virtual table. And where the data is not super transient and the data sitting in the Hadoop file system is relatively current, you can leave it there, do data federation, and combine it with data in IQ. And here's an example here where you might have point-of-sale data sitting in the Hadoop file system, and it's not transient. It's not changing in the last few weeks and months. It's static, and you can make use of it for combining with inventory data, for example, to predict and prevent inventory stockouts. And then our final method of integration is query federation. And this is very similar to data federation, where you're presenting the results of something in Hadoop, a MapReduce job, or before it was data federation with Hadoop file system. But now it's the results of a MapReduce job and combining that with data in IQ. And here's the case where the data is a little more volatile. What's sitting in the Hadoop file system isn't current enough. You need to rerun the MapReduce job, and you don't need to bring that data into IQ, but you do want to do some analysis with data that you do have in your database. And an example would be a utilities example where you've got smart meter and grid data, and you want to combine that with data in Sybase IQ to analyze demand and workload. So just in summary, we have in IQ an extensibility framework used for in-database analytics and for running MapReduce-like distributed processing right within the database using the distributed query processing and massively parallel processing capabilities of IQ. And we use that same extensibility framework for integrating with Hadoop. And then I'll pass back to David to kind of wrap up a summary here.
Yeah, absolutely. So thanks, Courtney, for that diving into that. And I've seen on the Q&A that there's definitely questions here which coming up around this, which is great to see. So the key message from our perspective is that Sybase IQ, we've really invested in making it a platform for dealing with big data analytics. And from our perspective, Hadoop and MapReduce are important tools. They're not the only tools. They're not, sometimes I think actually that there's an overemphasis on Hadoop as a big data solution. But it definitely has its place in the ecosystem. From our perspective, what's core is that companies have invested heavily in database-centric computing. Not that necessarily means that it needs to stay, that it can't be replaced. But there's a huge investment there, and there's a lot of skill set there. There's a lot of capability. And really the goal, from my perspective, with big data projects is it's not just about dealing with the big data, but how do you, analyzing that is important. But for example, on this diagram here, a big question is how do you build a life cycle or an ecosystem to deal with big data projects in your environment? And in some ways, that's almost the bigger question, right? I mean, you have the data scientist who has to do some data discovery, but if all you did was data discovery, your big data projects wouldn't have a whole lot of value. It's not until you convert those discoveries into insights and leverage them in your organization, whether that's long-range planning, whether that is enabling frontline workers to make better decisions, maybe about applications coming across their desk or that kind of stuff, or whether it's actually built right into business processes, right? These insights are built in to make better product recommendations, for example, online, for upsell opportunities. Either way, those insights need to be converted into value. And the core there is to build an infrastructure or platform that enables you to do that. So that's Sybase IQ.
Okay, good job, good job. And yes, we have some great questions. And thank you, Courtney and David, for some very detailed slides. That's exactly the kind of thing we want to see in here. So I'm now passing over the keys to Robin Bloor. And Robin, I believe you now have the keys to the car. So go ahead and just tap down a couple and you get to yours.
Okay, I think I see me there. Actually, I kind of, before actually starting to this, I kind of would like to just say one thing about the concept of shared nothing and the concept of shared everything. And it's just, in the late 1990s, we did a lot of work on parallel database, and at that particular point in time, there were some products that were shared nothing and some products that were shared everything. And our conclusion at the time is that there's no fundamental advantage to either, because actually databases do well or do badly given particular workloads according to how well they manage the resources. If you have a shared nothing environment, you still actually, in one way or another, have to manage the mastering of the answer from all the nodes that come back. And if you have a shared everything environment, then in theory there's greater potential for bottlenecks, but if you're managing the resources very effectively, then the bottlenecks don't emerge. So I think that, I think that particular argument that was had then seems to be being had now is actually not a real argument. The real argument is, does an architecture work, and how well does it work under given workloads? And I'll throw that at Sybase after I've thrown a number of other questions to them. What I kind of wanted to do here was just talk about big analytics. Really, in my opinion, big data equals big analytics in the sense that while there are people out there that are assembling big data and building things like dashboards that are actually turn out to be very useful to them, the majority of people that seem to be going at big data are going at it in order to do analytics on it, And when you look at the analytics picture, there are effectively a couple of challenges. The first is being able to manage the data and the data flow in order to serve the analytics applications. And then the second is providing acceptable performance for the analytics applications. And into this mix, over the past, 3 years now, it's certainly been quite a long time, Hadoop started off as something that nobody knew about, to something that was vaguely interesting, to something that was very interesting, to something which all vendors had to take notice of because it was getting such wide usage. But it's worth saying that Hadoop fundamentally is actually a parallel development framework. That's what it is. That's what it was intended to be in the first place, and that's what it's designed to be. Now, there's an awful lot more to Hadoop now than when it started. And, people have done things like they've used Hadoop to do 3D rendering of cartoons. Hadoop isn't something that is just a big data thing. It happens to have associated with it, the HDFS, a very big file system, which is also fault tolerant, that allows you in one way or another to manage very large heaps of data with Hadoop. But it also comes with the fact that in order to actually run jobs on Hadoop, you kind of have to program them in MapReduce. MapReduce skills are actually not that common. And I was having a conversation a couple of days ago, and basically the conclusion that a number of us came to was that most of the MapReduce work that we would see wasn't done well at all. In other words, learning how to actually program in MapReduce can be a challenge. Actually, is a challenge for people who are not familiar with that kind of style of programming. And it needs to be, it needs to be learned. It isn't a, I'll just pick this up and use it thing. Anyway, Hadoop can both be a blessing and a curse. Obviously, the blessing side is you can download all this, and you can download lots of stuff. You can download Hadoop, you can download Hive, you can download Pig, and so on. There's lots of things that are being added to it that are improving its capability. And a lot of companies, in my opinion, are actually using it to prototype various things, and some of them are doing very intelligent things with Hadoop. And they're often doing it on, networks of fairly old servers, so it's not actually costing them very much. It might even be stuff that they wouldn't otherwise be using. So, Hadoop's a wonderful thing in that respect. But it is also a curse in the sense that it seems to have a reputation around itself for doing things that maybe it can't do. I mean, it's not a database, period. It just isn't a database. Even when you add on top of it, all the various plugins like Hive and Pig and so on and so forth, you're getting capabilities that are, let's say, database-like, but it still isn't a database, And if you were going to design a database, you really wouldn't design it with HDFS underneath because it's not fast, As a file system, it's the fact that you can parallelize it over a very large number of servers means that you can make it go very, very fast to do various things. But I would certainly, in most circumstances, put pretty much any column store database up against Hadoop and win the race on most of the kind of queries that could be thrown at Hadoop in that way. So it's like Hadoop is not a database. There's lots of things that it doesn't do that databases should do. However, it has its place, and it can be very, very useful. Okay, what I'm now going to do is confuse everybody. This diagram that was drawn by me and Mark Madsen, really, as part of what we were looking at in the Database Revolution paper that we produced and are about to publish, in actual fact. And we were trying in one way or another to position what we've called NewSQL, which is databases like Sybase IQ that are architected for big scale-out. And NoSQL, which are databases a bit more like MongoDB or, I don't know, there's a whole bunch of them out there that are fundamentally architected for, really for complex data. So what we actually wanted to do here is we wanted to at least separate things out, and as soon as you do that, you realize that there is actually a fair number of dimensions in the way that databases work. So what I'm actually now going to do is go through some of these dimensions. One is workload mix. What we would call the universal RDBMS was really good at mixed workloads, and there in LSQL, it runs out of steam on high read intensity or high write intensity, but right there in the corner it works really, really well. The scale-out databases that are fundamentally relational in nature, what we would call NewSQL, are also the same as the MPP RDBMS. So, they're read intensive, they're very good at data as long as it's data organized in tables. When you go into data complexity, you get the key value stores with distributed hash tables, and you get specialized databases that fill a capability there. And what's actually going on is that some of the workloads that are happening in those areas are far too complex for what we would say a typical column store relational database. So those are NoSQL things. And that's just one way of looking at it. But, going through the points at the bottom here, Hadoop is actually a key value store, right, and the parallel processing framework. It's not, a column store or anything like that, although you can get plugins to make it behave like a column store. Some NoSQL databases are distributed hatch table based. Some are specialized DBMS that actually work in completely different ways. All of them are aimed to scale up. That's why they've got a life at the moment. Column stored databases, and Sybase IQ is one, they vary. But in general, they're MPP relational databases and NewSQL DBMS. They fit into that, and that means that by and large they can sit over petabyte level data. I don't guarantee that for every product in that space, but I certainly think it's true of Sybase IQ. Now, the next thing to say is that there's a fundamental idea of scaling up, but scaling up has 3 dimensions, and it's just kind of worth mentioning that that's the case. You know, one is actually big data volume, but you can have huge data volume in one big table, actually even a very sparse table, and your only problem in processing that is actually dealing with the volume of itself. If all you want to do is to have a series of queries, got it. However, if you actually have got lots and lots of users, and by users I also don't just mean people, I mean various pieces of software that want to use the data, then you have a concurrency issue. And there are situations where you will have hundreds, maybe even a couple of hundred, maybe even 600. I've come across that situation. Concurrent queries going at the same data. Well, you know, databases that scale up for data volume may not scale up for that kind of concurrency, and actually Hadoop can't do it at all, you know. And then you've got the computational thing, which is part of what we're kind of talking about here with Sybase IQ, some of the new capabilities that have been added. You've also got the fact that you may be doing analytical activity against a large heap of data, and how you handle the computation, if a computation is actually being done efficiently, which means, as has already been said today, bringing the algorithm as close to the data as possible, that affects on what you can do. So these are just 3 fundamentally and sometimes competing scales along the idea of scaling up, right? And the 4th thing here is that data flow architecture is a factor too. So let me talk a little bit about data flow architecture. I've represented this in a particular way, but you know, the truth of the matter is we don't get data coming into an organization and then all of a sudden we throw queries at it. What we actually have to do in one way or another is prepare it, bring it to a place where there is the resources required, whether that's CPU resource, memory resource, or whatever, in order to do the workloads that we want to stick against that data. So we end up with a data flow. And we had a data flow a long time ago that everyone's really familiar with. You know, you had these transactional systems, and they would there would be a data flow using ETL tools, possibly to a staging point, fed into a data warehouse. And the data warehouse, that you would be taking data marts off that, and some of those data marts might be specialists, like there might be OLAP databases and so on and so forth. And you might even be, you know, using those data marts to clone PC level data for people to investigate with Excel or whatever else they got. You know, and that's a big data flow architecture. Well, it didn't go away. You know, because we got big data, and just because in one way or another there's some interesting things that one can do against these, you know, very rapid flows of data that build up into very big heaps, you know, you've still actually got latency issues. And the whole thing about doing any kind of workload on anything is that you want an answer at a speed that makes the user's job as easy as possible. So we have in-memory databases or in-memory data stores where the reason it's all in memory is you've got extremely low latency, and you never have to go to disk, and because disk is about 100,000 times slower than memory, or even slower than that, I don't know the latest figures, then you know you're holding the stuff in memory, and you're doing that. So you know, part of what you will be doing within any kind of data flow arrangement may be to just actually feed an in-memory capability, or you get low latency, and this is much more like the analytical kind of work that Sybase IQ does, which is incidentally fast. You're not talking here about waiting minutes, unless actually you ask really, really big questions with lots and lots of stuff happening to it. But that kind of latency isn't the same as users getting instant answers. It's a bit more like users having to wait a while for an answer. And that kind of depends on circumstances. And then you have the higher latency thing, which is just getting the data in and making the data available for use and pushing it to the right place. And by the way, this is a simplification. It can be much, much more complicated than this when you start adding the dimensions. So this is a data flow issue. And the reason that, having looked at Sybase's slides when they were sent to me, the reason that I thought I'd talk about this is that there's a very big question, given what Sybase is doing, and that would be, what is the right way to use Hadoop with Sybase IQ, or even with any product that's like Sybase IQ in the way that it behaves? And that's a question that I kind of will be asking, but before I do that, I will just put this summary slide up. First of all, big analytics is here to stay. Those big heaps of data are not going away. In some analytic application areas, speed is desirable. In other areas, speed is absolutely critical, which is why you've got this data flow issue. Big warning, workloads can be mixed. And if you've got mixed workloads, you've got a data management issue on your hands, and that may not be addressable just with one product. It depends upon the context. It depends entirely upon the workload and the service level you want from it. Analytical speed depends upon the database engine, but it also depends upon the data flow architecture. So this is not necessarily a simple thing. It's not that I'll just buy a product and we'll fix it all. And finally, take the business view. Business effectiveness depends upon the integration of all of this stuff with the business process. So, even if you get all of the underlying infrastructure right and you get the applications right, if the business doesn't know what it's doing, then it won't do much particularly useful with what it's actually got. Having said that, what I'd like to do, this is nearly all going to be for Courtney in actual fact, but I'm going to postpone to the end this question of shared nothing and shared everything. We could get into a very long conversation about how Sybase IQ works, and I'd rather that was done not with me, who has been briefed on that about 6 months ago and knows fairly well, but possibly Eric asking questions or the audience asking questions. So what I'll just do is I'll ask questions about what I think the interesting things that Sybase IQ appears to be doing at the moment, and try and pin some of this down. So the first question, he's got a lot of pre-built functions, which obviously you've partnered with somebody else to put them in the database. Is the intention here to make some analytical tools unnecessary, or is it simply that you're expecting all of these capabilities, functions, if you like, to be called directly by such tools? I mean, what's the position here, Courtney?
I would say that we're not intending for analytical tools to become unnecessary. These analytics are very sophisticated, and not only does the processing have to be done, but it needs to be presented in a way that is understandable by human beings, and thus analytical tools are very important for users and useful tools. We make it a lot of analytical functions available to these tools that run right within the database, so it makes them more capable and able to present more interesting analysis to the end users. That said, with such a wide variety of functions that are available, some of them are fairly simple and easy to get your mind around and easy to use in a simple query, so you can use them directly as well in your own queries. But I would say generally we're not trying to take away the use of analytiul tools.
If I can jump in here, actually, a great example of this, Robin, is with the predictive markup model language support within Sybase IQ. So that is, the intent there is actually you would use a third-party tool like SAS, for example, and you'd create your model in SAS, you'd export it, and you'd actually be able to export it and then import it into IQ and run it directly. At SAP, we just released or announced a new predictive analytics tool called Predictive Analysis. We got really creative with the name there. The but it's a brand new tool. So there's actually a tool where it will be actually calling directly the in-database analytic libraries.
Yeah, so I figured you would be doing that. That's very logical, isn't it, to have done that? What I'd like, and this could be either of you, whoever wants to jump in, but what is the SAP view on how Hadoop could be used? I mean, you've done a lot of things to integrate in various ways with Hadoop here, which is fine. But I personally think that the organizations that are using Hadoop are probably will be very happy to hear anyone say how they think Hadoop should be used, especially in connection with Sybase IQ itself. So, what's your position on Hadoop in that sense?
Well, why don't I, Courtney? Why don't I kind of take a first crack, and I'll let you jump in. So, I actually like the slide that you showed. Not your I liked your summary slide. I shouldn't say that, but the slide before, the visual diagram where you showed the latency levels, so I completely agree with that kind of model. I would actually also put another label on some of those, and that would be where typically, for example, where you have high latency, you would also have high value data. All right, so at one end you have high value data, at the other end you have data that you don't know the value of the data. It could be extremely high value. It could have no value. And what we've seen with some of our early adopters of Hadoop, and integrating into the SAP databases, that is often how they're using Hadoop, is to say, you know what, let me just take all of this data I'm collecting, let me just stick it somewhere that's inexpensive, and I will have some process that says, hey, what is, help me, I will go through a process that uncovers the data in here that's of value. And the data that is of value, I will actually move up the chain and into other systems for further analysis. But from my perspective, that makes a lot of sense because, your typical data warehouse or analytic database for that matter, the IT department's often very strict, right, about what data goes in there, the process that you go to cleanse the data, prep it before it gets loaded in, right, so you know that it's very clean data and ready for analysis. But you're not going to spend all that time, go through all that expense for data that you have no idea if it has any value to at all. And so Hadoop's, that is one example where Hadoop's a beautiful solution in my mind for this. The other area I think is really dealing with what you touched on, which is there are some algorithms that, in data structures that just don't make sense to represent in a SQL relational database. And, it becomes very onerous to try and create an algorithm that works within that kind of environment. Partly we've tried to get around that with our own MapReduce API, right? So you still have to represent the data in a table. But the algorithm doesn't have to be, describable in typical SQL. But there may be, data representations and algorithms that don't even make sense in the database, and you actually want to run that in Hadoop as well.
Well, right. I mean, I go with both of those. I mean, the first thing is that where I've seen Hadoop used, mostly it's being used for what I would kind of characterize as ETL. You're going to extract from it. And you might be using the MapReduce algorithm to do little bits of transform while you're doing it. So, it's a kind of ETL rule, but not ETL role, but not the kind of ETL that we're normally familiar with. And the other one is because HDFS is really a key value store, so you can put a key in and pretty much any structure underneath the key, as long as you can actually program in MapReduce. Then yes, you can put lumpy data in there, and you can grab the lumpy data out of there, possibly in a way that you can put into a relational database. So both of those things seem to be quite valid for me. But I mean, it is a parallel framework. So at the end of the day, using it to do good parallel activities is valuable. Anyway, let me move on to I've got some very trivial questions. You talk about doing joins out of Sybase with Hadoop. Is that Hadoop plus Hive? Or alternatively, where is the schema that allows you to see what's in Hadoop? How does that work?
Based on what's in your Hadoop file system, you can represent that structure as a table with some columns. And so that lets you represent the data as something that looks like a virtual table. And there's a process for doing that. And once you've done that, then in your definition of the function that's going to go call out to Hadoop, we'll have that structured format. Then you can link in that function and invoke it like, select it like any other table in the database.
Okay. There's another thing. You've gone through, you know, and this is actually bundling a few questions together, but I'm kind of running out of time. So, you know, you've gone through a different set of scenarios by which you can actually use Hadoop along with Sybase IQ. One is to use it all from the front end so that you can be accessing Hadoop separately. Other things is you've got joining of data between Hadoop and Sybase IQ. There's a kind of subsidiary question to this, which is all of those useful analytical functions, can you throw them at Hadoop data when you do joins like that? But you know, the other thing is, like, what's the role when you're actually thinking of using Sybase IQ with Hadoop? What are the kind of scenarios, or what's the kind of role that you see for that? What's the business situation, basically, is what I'm saying.
To use the two together, like, for example, with the joins.
The two together. I mean, because, you know, what you've got actually is you've got a lot of capability that allows the two to go together, especially this join thing, which I find intriguing. And if I had Sybase IQ and Hadoop to play with, I'd probably sit around all afternoon doing joins and seeing what that happens.
Well, we do have a little Hadoop demo where we take the results of the basic word count job that comes with the Hadoop distribution, and we join the results of the words that are found with size data in a product database. It's a sort of a very loose kind of example of what you can do. It's sort of modeling a case where you've got a big sales promotion and you're looking at requests or interest in a particular item, and then you want to join that interest with actual inventory data that you have in the enterprise data warehouse. You might be joining product names and sizes and trying to get an estimate whether you can actually satisfy that, that huge sales effort. So there's one very simple example. In the slide deck that we showed some possible examples of utilities joining meter data with customer loyalty data and that kind of thing. E-commerce, you know, clickstream data with actual sales data in the enterprise data warehouse, where you can join these two together and derive some kind of insights from them, and using these different integration methods.
And I think that to add that, I think the crux, in my mind anyway, the key to the answer is actually what is your Sybase IQ database? Because if your Sybase IQ database is just like a scratch pad, right, that your data scientist is using, then, you know, doing the join across them may or may not make sense, right? I mean, if you don't really care what's in the data or what's in the database at some level, right, that maybe it's your own sandbox, you know, you can muck around as you see fit. But if your Sybase IQ database is actually an enterprise data warehouse, right, and kind of back to this example where, you know, you've cleansed the data and you've been very careful about what you actually store in that. Now you actually want to do this data mining. You've got this question, right, that you're trying to ask, and somehow you need to cross-join, you know, the product inventory, for example, that Courtney was talking about, with some other bit of information out of Hadoop. You don't know if that bit of information is going to be relevant or not, right? It's kind of an exploratory phase, and you're just running these queries. But, you know, you don't want to go through the effort to cleanse it and put it into the data warehouse and fight with IT to do that. And maybe you don't want to export the data and plunk it into Hadoop, right? So you now at least have another tool, some flexibility to be able to you know, keep the data where they are and do some analysis across them.
Okay, I'm going to have to hand back to Eric because I've gone way beyond how much time I was supposed to have. So Eric?
No worries at all. There's a lot of good detail. And folks, one of the reasons why Robin was going into a lot of that detail is because, drum roll please, we are about to unveil our final report on the database revolution. You can find that at databaserevolution.com. It should be probably tomorrow or the next day or in the very, very near future. We're just kind of dotting I's and crossing T's. But we do have lots of great questions here, folks, so I'm going to go ahead and take back the keys and start throwing some of these over to you. And I'll just throw it over to the team over there and whoever wants to jump on it, fair enough. So I know that Robin talked about this a little bit, but folks over at Sybase, can you talk about this shared nothing versus shared everything? One of the attendees writes, you're going to have to explain shared everything versus shared nothing. Does that mean that each server has a virtual connection to all other servers? The virtual shared disk was needed on the IBM SB2 for Oracle and was not a good idea.
Yeah, so why don't I take I definitely opened up a can of worms here, didn't I?
Okay.
But it's a great question, and you know, fundamental. We really think that we, you know, to Robin's point, at the end of the day, you know, shared nothing versus shared everything. When it comes to running a query, depending on how you architect it and run the query, you can get some results. We really believe that shared everything will give you a lot of flexibility and scalability too. Now, scalability as it relates to users, you know, that is really where we're going to shine. As you add more users onto the system, shared everything is going to perform well. So now, our shared everything, really what that means is that you have a shared disk and all the data is stored there, and then the servers are actually able to communicate with each other. So you can do massively parallel processing. So for example, if we take a look at the slide that's up here right now, right, you could have a query that comes in to say the green node on the far left, and that green node could actually break up the query and run it across all 4 green nodes. Okay, and or it could run across 3 green nodes or 2 green nodes, whatever it thinks that the number of nodes it needs to answer the query. But all of those nodes actually have access to the shared disk, which is at the bottom. And well, assuming that the administrator gives them access to all the database files on that shared disk, then they can access that. I mean, you can control, right, who can access which database disks. Or databases, if you like, on the storage area network. But the key from our perspective, there's 2 really key elements, and the first is that it's not always faster to use more machines. Okay, often we think that that's the case. Well, actually, you know what? I apologize. Let me step back actually for a minute and address the perception that shared everything has lots of bottlenecks at the disk. I think that perception really came around because shared everything primarily was used with transactional databases early in the day. Okay, it wasn't targeted toward analytic databases, and so the bottleneck became around writing the data to the disk. That is where Oracle RAC struggles. That is actually, frankly, where ASE Cluster Edition can scale out with lots of read nodes, just like Oracle RAC can. But when you start to have multiple nodes writing to the disk, it becomes a bottleneck, right? It's like everyone's trying to get through that same small pipe. But when you talk about analytics, it's a little bit different, right? You're not locking up tables and that kind of stuff, you know, so one guy can write to the disk and everyone kind of waits in a queue. You can actually have a lot of people reading off the disk. Okay, so that's one element. The other element is that you have a columnar database with IQ there on the disk. So you're actually reading a whole lot less data. Okay, so you can have more users reading, they're reading less data off the disk, so you have even far less contention. But where you run into problems with scalability in a grid architecture tends to be when you're collecting all the data. Okay, before you send it back, your response back. So, for example, let's imagine that we've got this grid here. We've got 8 machines from my count. One machine is going to be the kind of the lead node, and it is going to parcel out all the work to the other 7 machines. Well, when those 7 machines have finished their work, right, they're going to hand back the results to that 1 leader node. That 1 leader node then needs to collect all that information, compile it together, and give back a response. The more nodes it has to coordinate to do that, actually, the greater the bottleneck that node becomes. Okay, so essentially, the bottleneck actually becomes with the server as it's trying to kind of aggregate the results and send it back to the user. The other thing is that the challenge you often, or not a challenge, but you have this kind of law of diminishing returns, right? So imagine I've got 10 nodes, all right? If I add another node, you know, I get maybe at maximum theoretically a 10% gain, right? So if I have 100 nodes and I add 1 node, I get a maximum, you know, theoretically of 1% gain. Okay, so the more nodes I add, you know, the less benefit I get. So your biggest benefit is actually going from 1 node to 2 nodes, right? And you know, you kind of have this law of diminishing returns. So this is where the user scalability challenge comes in. If you use a shared nothing architecture, essentially what you're saying is that I've split my data across 10 machines, let's say. We'll use the example of 10. And every time I ask a question, I must use 10 machines. It doesn't matter if, you know, 4 machines might be faster for me because there's overhead with collating the data, right? That's irrelevant. I must always use 10 machines. It also doesn't matter if I've got, say, 10 people that all want to make a request, okay? If I've got 10 people that all want to run a query simultaneously, you know, it's this question, is it faster to actually, you know, have the 10 people wait in a queue and each go 1 at a time against the 10 machines? Or is it actually faster to give 1 machine to each of the 10 users and let them run their query on that 1 machine? And, you know, from our benchmarks and our internal studies, we found that it's actually faster to give each user 1 machine, to cut out the coordination that needs to happen, so on and so forth. And, you know, I've got a whole presentation I could go through, right? We could literally, like Robin said, we could literally spend an entire hour going through this and articulating, you know, why we think shared everything is very scalable and flexible. But hopefully that helps. I know it was just kind of, there weren't any visuals to go along with it, but hopefully that kind of helps to answer some of that question.
Yeah, that's good, because we did have several questions about that, so thanks for that. This is actually a very specific and very good question from an attendee. One of the attendees writes, we use Power Designer here. How would I model Hadoop data as a data model? And can I pull in data elements from Hadoop models to a BPM diagram in Enterprise Architect?
That is not available today, but I believe that is, you know, in the discussion stages and roadmap stages, because we recognize that's very important. Power Designer is a very broadly used modeling tool. SAP has embraced it, and we think that that's probably one of the next steps that's coming for Power Designer.
Okay, good. And so a number of other really good questions here. A lot of people are asking about HANA, and we've got a couple questions about CEP, complex event processing. Can you talk about where people should look to HANA versus Sybase IQ in this environment, and where, you know, where people should work with Sybase IQ instead of HANA?
Sure. So the first is that when it comes to Hadoop, for example, SAP, a lot of the products are actually working on a roadmap that says how do we actually work with Hadoop and integrate. So for example, so to Courtney's point, right, with Power Designer, it's on the roadmap. There's lots of other products that are further advanced. IQ, obviously, Sybase IQ's had it in market for some time, the capability. We actually just announced last week at Sapphire that a number of our SAP EIM products now integrate with Hadoop environments, so you can actually load data to and read data from both SDFS as well as Hive environments. Okay, business objects, SAP Business Objects. I don't know if it's released, so maybe I'm letting the cat out of the bag, but I think it's been released. But it has the ability to actually run queries against a Hive environment, so that you can, run basic queries and that kind of stuff. HANA has also last week announced its ability to integrate with Hadoop environments as well. In fact, we have a number of customers that have already done that in POCs. So everyone's taking a look at how do you build essentially these, to Robin's point earlier, what I call an information value chain, right? My low value data, my high value data, and I've got a way of moving that back and forth, often between low latency and high latency kind of systems. And so we're working on all of our products to fit that together. So the question becomes, so the other question we had here was, how does SAP HANA and Sybase IQ come together? And the important answer here is that it's not a versus. They are actually fundamentally, from our perspective, play different roles. Definitely there's overlap, but we've actually had lots of customers actually buy the two products together. And while HANA has, we've done benchmarks. In fact, we actually just put out a press release last week that talks about a 100 terabyte system with HANA. And the cost of storing data in memory has come down significantly. We believe that there's a lot of people that are going to say, look, I don't want to stick all of my data in HANA. That sticking it in memory today might be an expensive value proposition. That it really comes down to this, what I would call this information value chain, right? I'm going to put all the data that has like questionable value or no value, in Hadoop. Right? I don't want to spend any time, cleansing it or anything like that. I just want to plunk it somewhere and be able to analyze it and find the nuggets of high-value data out of that. You're also going to have lots of information in your organization, transactional information that you're generating, and you're going to want a place that's low cost place to put that. Sybase IQ is a perfect database for that. Okay, so that you can take all your transactional information. It probably doesn't make sense for you to take all the data out of your transactional systems and plunk it into Hadoop. Okay, you spent all this time kind of giving it structure. Keep that structure in your database. You've got the infrastructure to do it. People have enterprise data warehouses, all that kind of stuff. And then the vision for HANA is very much to do analyze and transact on the same database. That is its path forward, and it's all about low latency. It's all about high value data. I do not anticipate that people are going to spend a lot of time sticking data of little or no value into HANA. It just doesn't make sense. And so you have this information value chain that says, hey, HANA for the highest value data, IQ for all your enterprise data, that's still of value to you that you just might not need in your analysis or transactional systems or whatever it is today, right? And then all your questionable or no value data in Hadoop.
Okay, good. And yeah, we've got one comment here. So IQ is OLAP and HANA is OLTP, data in motion versus static data analytics. Is that typically the good summation?
Well, so HANA does OLAP as well. Okay, so the OLTP part is a vision. So, for example, the common use cases right now are using HANA, for example, under Business Warehouse. SAP NetWeaver Business Warehouse is a big play for that. We do have other customers that are loading their data out of their ERP system and putting it into HANA. But they may not be dealing with hundreds of terabytes of data, for example, right? Which you can very cost-effectively stick into IQ. Lots of customers do that.
The real sweet spot for IQ is a high number of concurrent users, large amount of data, and ad hoc queries. You put those three together, and Sybase IQ really excels.
Okay, good. That's very good feedback. And I got a couple more really specific questions for you, if you could get to, and then we'll wrap it up. We always try to go along if we get a lot of good questions, and boy, do we have a lot of good questions. One of the comments, or one of the questions here is around cost. I know that's always kind of a delicate issue to talk about, but can you speak to cost? And one of the attendees wanted to know about setup. I'm guessing that you can purchase services. I'm curious to know how much in the way of services are included, and is it just how do you bill all that stuff?
Well, okay, so from a licensing perspective, I won't necessarily dig into the costs, But let me tell you this. Right now, SAP actually has this wonderful migration program, and so if you actually purchase licenses of Sybase IQ or actually any of the SAP databases, that in fact they will give some free services to go along with that. Now, having said that, let's talk about, let's look at the overall total cost perspective. And so Sybase IQ is actually often very easy to set up. In fact, we often relish the opportunity to go in and do a POC because it's very easy to get in there and install Sybase IQ. In fact, you can actually just download it. There's an search Sybase IQ Express Edition. You can download it for free. It doesn't give you the ability to stick a lot of data in there, but it gives all the functions and features and capabilities, and you can actually try it out. You can see how quickly you can get it installed and running. And because there's no restrictions in terms of your schemas, you can actually just copy your data from your other transactional system or data warehouse or wherever, plunk it into IQ and start running with it. So often we can do a POC in a couple of days against real production data, and then it goes. Then the costs really come down. Like we have a customer called Digiturk, and they had an Oracle 11G data warehouse. They did a POC with IQ, and discovered that the queries ran 6 times faster just out of the gate. They didn't do anything to the database, no tuning or anything. And we thought, well, that's, to be honest, actually, we didn't think the performance was that great. That was 6 times faster. You can do better than that. But the customer didn't actually care. They said 6 times faster is fast enough for me, but I've actually cut out 75% of a DBA's time because they don't have to create indexes or aggregates or anything like that. The big kicker was that they were actually running it on half the hardware that their Oracle environment was on. So there was a huge cost savings for them in order to do that. So.
And can you talk about, one of the attendees wanted to know which hardware vendor supported that 100 terabyte HANA implementation, I think is what you're talking about. Can you reveal that?
Yeah, actually, I think it's in the press release. You know what? Why don't I Google it while why don't we take the next question? Okay. And I will Google it and give you the answer. We've
got some real-time research going on here, folks. We have just a couple other really good questions here. One of the attendees wanted to know about, let me get to it. And folks, we will archive this webcast, by the way. We do archive all of these webcasts, so feel free to hop online. One of the attendees wants to know about support for C language libraries as well. Does that come built in?
You're talking about the extensibility framework?
Yes.
We provide, yes, it's C and C++.
And the fuzzy logic stuff, does that go through R, or how is that implemented?
Fuzzy logics are their own built libraries of functions in C++, and those are provided as a set of linked libraries that you can load into IQ. We have an integration with R in a couple of different ways. This PML plugin, for example, in the R server, you can take a PML model and build an R model and generate it as PMML. Then you can take that PMML, run it through Zementis, generate Java, and run that inside Sybase IQ. That's one thing. Also, through this extensibility framework, we can invoke the R server, an application running in the R server, and bring the results back as a virtual table. And also, from R, we have certified RJDBC for that R application to access Sybase IQ and bring data into the R application. That's kind of our story around R.
Okay, that's good. And just one last very detailed question I'll throw over to you folks, and then we will wrap up. But excellent questions, everybody. Thank you so much for all these. One of the attendees writes, do you build your own indexes into HDFS when integrating HDFS files without importing the data? That's pretty technical.
No, we don't. We simply use the Java functions to access HDFS and read the file as you would read any file. So there's no special indexing that we do on top of that.
Okay.
Now, if you use ETL to bring Hadoop data into IQ, which you can do, Then you can treat it as an index table for fast access and ACID type properties.
Okay, good. And did you find an answer on that hardware thing? If not, we can post it later.
Yeah, I did not. It doesn't look like it was actually part of the press release. We do mention 3 of our hardware partners. Fujitsu, HP, and IBM were 3 partners mentioned in the press release. But
I think it was IBM for the 100 terabyte system, but I don't remember which
configuration
product. Yeah.
So so HANA actually supports 6 different hardware vendors and quite a few different profiles. But I think you might be right on that. I think it was IBM.
Yeah, we've got an interesting comment from one of our regular attendees who notes that IRS Research Analysis and Statistics uses Sybase IQ for their compliance data warehouse, which has 1 petabyte of shared storage. So they're keeping track of all of us, folks. Well, guys, thank you so much for all of your excellent questions. A very big thank you to our friends from Sybase IQ, which, of course, is now an SAP company. Very big thank you to Robin Bloor for some additional details and information. As I mentioned, we do archive all of these webcasts for later viewing. I will once again push the bit.ly for the archives here to the chat section, so anyone who wants that, by all means, do check that out. You can check it out anytime at insideanalysis.com. Here it goes right now. And please do pass this on to your friends and colleagues, folks. We really do appreciate any work you can do to spread the word about what we're trying to do here in the briefing room. So with that, we're going to sign off, and we'll catch up to you next week when it's Teradata. So we had SAP this week and Teradata next week, again, talking about big data and integrating with Hadoop. So it's exciting stuff, folks. That concludes our event, and presenters, just stick around for a quick minute for a post-conference. Take care, folks. Bye-bye.